Salam uşaqlar, axşamınız xeyir. Necəsiz? Bugün deməli biz 55-ci gündən davam edirik. Yes, 55-ci gündən davam edirik və bir də səs falan yoxlayaq. Okay. Şey qaydasında olmalıdır. Hər şey qaydasındadır. Gəlin davam edək. Deməli biz qalmışdıq harda? Buralarda bir yerdə. Elə buradan davam edirdik. Latency trough-da baxdıq. Consistency pattern. Yox, bunlara gəlmədik, çıxmadıq. Capture-a baxdıq. Consistency-yə baxardıq deyəsən, hə? Bir dənə bunu da çatı açın bu hissədə. Çatı var. Deməli, consistency patterns. With multiple copies of same data, we are faced with options on how to synchronize them so clients have a consistent view of data. Recall the definition of consistency from CAP theorem. Every read receives the most recent write on an error. With consistency, after a write, reads may or may not see it. Best effort approach is taken. This approach is seen in systems such as memcached. Okay. Weak consistency works well in real-time use cases such as VoIP. What's this? Voice over internet. Video chat and real-time multiplayer games. For example, if you are on a phone call and lose reception for a few seconds, when you regain connection, you do not hear what was spoken during connection loss. Eventual consistency. After a write, read will eventually see it. Typically within milliseconds, data is replicated synchronously. This approach is seen in systems such as DNS and EMEA. Eventual consistency works well in high available systems. Strong consistency. After a write, a read will see it. Data is replicated asynchronously. This approach is seen in file system and RDBMS. Strong consistency works well in systems that need transaction. Source for further reading. Bence bunu daha etraflı okumaya ihtiyaç var mı ki? Nerede bu? Of three properties of distributed system: consistency, availability, partition tolerance. Choose two. Okay. Scaling is hard. Multi-homing, operating from multiple data centers simultaneously, serving data processing, read-only data, read-write, hardest kind. Case study: App Engine data store. Consistency, transactions, buy across data center, multi-homing, techniques and trade-off. Conclusion: weak With consistency after right. Okay. Elə bunları deyəcəkdinsə bunları bilirik də. Well, bu lazım deyil. Availability pattern the two component the two complementary pattern to support high availability failover and replication. Failover, active passive. With active passive failover, heartbeats are sent between active and passive center on standby. If the heartbeat is interrupted, the passive server takes over active's IP address and resumes service. The length of downtime is determined by whether passive server is already running in hot standby or whether it needs to start up from cold standby. Bu hissəm biraz başa düşmədim. Nə deyir? Active, passive, deməli failover, heartbeat are sent the active and passive server on standby. Aktiv və passiv serverlərə göndərilir. If heartbeat is interrupted deyən channel deyir. Heartbeat göndərmir, interrupt oldu. Onu mu demək istəyir? Passive center takes over active's IP address and resume service. Çox maraqlı. Əgər heartbeat interrupted olursa server niyə onun yerini götürür ki? The length of downtime is determined by whether passive server is already running in hot standby or whether it needs to start up from cold standby. Okay. Only active server handle traffic. Yəni active server handle edir trafiki, passiv eləcə dayanıb. Əgər passiv işləyirsə, bu deməkdir ki, downtime mövcuddur. Active passive failover can also be referred as master-slave failover. Başa düşdük. Active passive failover, master-slave failover. Active failover. In active, both servers are managing traffic, spreading load between them. If the servers are public-facing, DNS would need to know about the public IP of both servers. If the servers are internal-facing, application logic would need to know about both servers. Active failover can also be referred as master failover. Okay. Disadvantages failover. Failover adds more hardware and additional complexity. There is a potential for loss of data if the active system fails before any newly written data can be replicated to the passive. Master-slave, master-slave, master-master. This topic is further discussion in database section. Master-slave replication, master-master replication. Oy. Baxaq. Burada database gələnə qədər hələ. Yox, elə bir balaca qalıb gəlir bu hissələrə də. Okay. Availability in numbers. Availability is often quantified by uptime, Getdi ora, niyə getmirəm? Nice. Availability is often quantified by uptime or downtime as a percentage of time the service is available. Availability is generally measured in number of nines. A service with 99% 99.99% available is described as having 4 nines. Okay. 99.9% availability 39. Downtime per year. İllik bu kadar. Aylık, haftalık, günlük. Okay. Availability 49. Günlük. Availability in parallel versus in sequence. If service consists of multiple components prone to failure, service overall availability depends on whether the components are in sequence or in parallel. Availability-də deməli komponentlərin paralel və ya sequential olmağından asılı olaraq dəyişir. Overall availability in sequence decreases when two components with available less than 100% are in sequence. Total availability, okay. If both foo and bar each reach 99 availability, their total availability in sequence would be 99.8. In parallel, overall availability increase when two components with available less than 100% are in parallel. Totalı da bərabərdir. Bir çıx. Bu. Vurulsun bir çıx bu. Sonra da onu birdən çıxırıq. Okay. Əgər ikisi 99.9% available-sı total 99. Nəsə bu qədər 9 olur. Yəni deməkdir ki, paralel olanda bunların availability-si daha yüksək olur, nəinki in sequence. Okay. İndi gəlir domain name serverdən danışır. How does DNS works? Necə işləyir? Aha. Gəlir burada bir dənə client deyir ki, I need direction to google.com. Great, I know how to get to google.com. Bu da neyinir? Gəlir IPC serverə. Great, I will put that in my cache in case I get another request. That domain is not in my server. I will ask another DNS server. Okay, belə baxaq. Bu qırmızı gəlir deyir ki, mən getmək istəyirəm direction-a. ICP serverə, DNS serverə deyir. DNS server gəlir, baxır bunda var mı, varsa göndərir. Yoxdursa gedir root DNS serverdən götürür. Aha. Gətirir bura qoyur. Bu da gedir həmin IP-yə. Nedir bu? Syrian Electronic Army. Distributed reflection DDoS attack. Combining reflection and amplification. Use third-party open resolver in the internet. Attackers send spoofed queries to the open recursive servers. DNS DDoS for hire. Neyse bu burada. Domain name server translate domain name such as w.example.com to an IP address. DNS is hierarchical with few authoritative server at the top level. Your router or ICP provider provides information about which DNS server to contact when doing a lookup. Lower level DNS server cache mapping, which could become stale due to DNS propagation delays. DNS results can also be cached by your browser or operating system for a certain period of time, determined by time to live (TTL). OK. NS record name server specifies DNS server for your domain subdomain. MX record mail exchange specifies mail server for accepting messages. R record points a name to an IP address. CNAME canonical points a name to another name or CNAME. Example.com to www.example.com or to a record. Services such as Cloudflare and Route 53 provide managed DNS service. Some DNS services can route traffic through various methods. Weighted round robin prevent traffic from going to server under maintenance. OK. Balance between varying cluster size. A/B testing. Latency based and geolocation based. Gəlin bir baxaq. Comparing the load balancing algorithms.
Hello there. And you're watching another JScape MFT Gateway tutorial. In today's video, we'll talk about 5 different kinds of load balancing algorithms.
Yaxşı oxuyaq. Round robin is undoubtedly the most widely used algorithm. It's easy to implement, easy to understand. Here's how it works. Let's say you have 2 servers waiting for requests behind your load balancer. Once the first request arrives, a load balancer will forward that request to the first server. When second request arrives, presumably from different client, that request will then be forwarded to the second server. Because second server is the last in this cluster, next request will be forwarded back to the first server for second, so in cyclical fashion. As you can see, method is very simple. However, it won't do well in certain scenarios. For example, if server 1 had more CPU, RAM and other specifications specs than server 2, server 1 should be able to handle higher workload than server 2, right? Unfortunately, a load balancer running on a round-robin algorithm won't be able to treat 2 servers accordingly. In spite the 2 servers disappropriate capacities, the load balancer will still distribute requests equally. As a result, server 2 can get overloaded faster and probably even go down. You wouldn't want that to happen. A round-robin algorithm is best for clusters consisting of servers with identical specifications, I think. For other situations, you might want to look at other algorithm like ones below. Weighted round-robin. For the second scenario mentioned above, server 1 has higher spectrum specifications than server 2. You might prefer an algorithm that assigns more requests to the server with a higher capability of handling greater load. Such algorithm is weighted round-robin. Is similar to round-robin In that way, requests are assigned to the nodes in still cyclical. Bunu necə təfsir?
Cyclical.
Cyclical. Okay. Albeit with a twist. The node with the higher specifications will be apportioned a greater number of requests. But how would the load balancer know which node has a higher capacity? Simple. You tell it beforehand. Basically, when you set up load balancer, you assign weights to each node. Node with high specs should, of course, be given high weight. You usually specify weights in proportion to actual capacities. For example, server 1's capacity is 5x more than server 2. Then you assign it a weight of 5 and server 2 a weight of 1. Okay. Əvvəlcədən biz bunları weight assign edirik. So when a client starts coming in, the first 5 will be assigned to node 1 and 6 to the node 2. If more clients come in, the same sequence will be forward. Bunlar gelir deməli server 1, digər gelir server 2, so on. Capacity isn't only basis for choosing the weighted round-robin algorithm. Sometimes you will want to use it if, say, you want one server to get substantially lower number of connections than equally capable server for a reason that the first server is running business critical application and you don't want it to be easily overloaded. Okay. Yəni demək istəyir ki, sadəcə kapasitesi böyükdür deyə bu algoritm istifadə edəməyəcəksən. Ola bilər ki, bir server business critical application run edir və sən istəmirsən ki, o çox belə overloaded olsun. Ona görə bunu istifadə edə bilərsən. Secure file transfer solutions like Escape MFT birinci dəfə eşidirəm. Help simplify complex IT environments by providing advanced encryption, automated workflows, and centralized management. These features enhance security, ensure compliance, and improve operational efficiency. Experience Escape for yourself when you start. Neyse bu reklamıymış. List connection. There can be instance when if two servers in a cluster have exactly same neyse de see first example figure. One server can still go overloaded considerably faster than other. One possible reason would be that clients connecting to server 2 stay connected much longer than those connecting to server 1. Əgər eyni deməli ölçülər varsa,
specs.
Okay. One possible reason would be clients connecting server 2 staying connected much longer than connecting server 1. This can cause the total current connections in server 2 to pile up, while those of server 1 which clients connecting and disconnecting over shorter times would virtually remain the same. As a result, server 2's resource can run out faster. This is depicted below, wherein clients 1 and 3 already disconnect, while 2, 4, 5 and 6 are still connected. Yəni demək istəyir ki, bu daha yavaş handle eləyir. Daha doğrusu bu task daha uzun çəkir. Ona görə bunlar dayanıb burada. Round robin işləmir. Bir ona, bir buna, bir buna olmur. Bu tez-tez həll edir. Bu sırf buna görə hamısı qalıb. The least connection algorithm would be better fit in a situation like this. This algorithm takes into consideration the number of current connections each server has. When a client attempts to connect, the load balancer will try to determine which server has the least number of connections and then assign a new connection to that server. So if you say, continuing our last example, client 6 attempt to connect after 1 and 2 have already disconnected, but 2 and 4 is still connected, the load balancer will assign client 6 to server 1 instead of server 2. Okay. Yani deyir ki, yoxlayacaq, görsün hansı serverin daha çox connection'ı var. Əgər hansı da azdırsa, yeni connection'ı ora göndərəcək. Weighted list connections. The weighted list connection algorithm does do list connection what weighted round robin does to round robin. What is it introduced? A weight component based on respective capacities of each server. Like in weight round robin, you must specify each server's weight beforehand. Load balancer that implements the weighted list connection algorithm now consider weight capacity of each server and current number of clients currently connected to each server. Düzmü başa düşdüm? List connection ama verilen weight qədər list connection mı? Okay. Bunun weight'i 0.5'di, bu 0.2'di, bu 0.2'di. Bunda 10 connection var, 12 connection var, bunda da 1000 connection var. Okay. Okay. Bunların weight'i 0.2'di, bu ikisi de eyni connection'lar var ama bu 0.5 olduğu için bunda daha çok connection'lar var. Onu demək istəyir. Weight'ini asıl olarak connection ora göndərəcək. Random, as its name implies, this algorithm matches client and server randomly using the underlying random number generated in case wherein load balancer receives many requests. Random algorithm will be able to distribute the request evenly to the nodes. So like round robin, random algorithm is sufficient for clusters considering of nodes with similar configurations. Random necə yaxşı ola bilər, mən onu anlamadım. Bu nədir? Latency based. If your application hosted in multiple Amazon Web Service regions, you can improve performance for your users by serving the request from Amazon region provider lowest latency. Data about latency between user and your resource is based entirely on traffic between users and Amazon data centers. If you aren't using resources in AWS regions, the actual latency between your user and your resource can vary significantly from latency data. This is true even if your resources are located in the same city as Amazon Web Service regions. To use latency-based routing, you create latency record for your resources in multiple Amazon Web Service regions. When Route 53 receive a DNS query from your domain or subdomain, example.com or example.com, it determines which Amazon Web Service regions you have created latency records for. Determine which region gives the user the lowest latency, and then select the latency region record for the region. Router 53 responds with a value from the selected record, such as IP address for the web server. For example, suppose you have elastic load balancer in the US West region and in the Asia Pacific Singapore region. You create a latency record for each load balancer. Here, what happens when user in London enters name of your domain browser. DNS routes the query to Route 53 name server. Route 53 refer it to its data and latency between London and Singapore region, and between London and Oregon region. If latency is lower than between London and Oregon region, Route 53 respond to query with the IP address for the Oregon load balancer. If latency is lower between London and Singapore region, router 53 responds with IP address for Singapore load balancer. Latency between host and internet can change over time as a result of change in the network connectivity and routing. Latency-based routing is based on latency measurements taken over a period of time, and the measurements reflect these changes. Request that's routed to the Oregon region this week might be routed to the Singapore region next week. When browser or the other viewer use DNS resolver that supports the EDNS client subnet extension of EDNSO, DNS resolver send Route 53 a truncated version of user's IP address. If you configure latency-based routing, Route 53 consider this value when routing traffic to your resource. For example, for more information, see Mənə. You can use latency routing policy for record in private host zone. For information about value that you specify when you use latency routing policy to create records, see the following topics. We don't need to. Geolocation-based. Geolocation routing lets you choose resources that serve your traffic based on geographical location of your users, meaning that location or that DNS queries originate from. For example, you might want all queries from Europe to be routed to elastic load balancer in Frankfurt region. When you use geolocation routing, you can localize your content and present some of all of your website in the language of your users. You can also use geolocation routing to restrict distribution of content to only the location in which you have distribution rights. Another possible use is for load balancing loads across endpoints. Is predictable, easy to manage way, so that each user's location is consistently routed to the same endpoint. You can specify geographic location by continent, by country, or by the state in the United States. If you create separate records for overlapping geographical regions, for example, one record for North America and one for Canada, priority goes to the smallest geographic region. This allows you to route some queries for a continent to one resource, and to route queries for selected countries on that continent to different resources. Gəlin locationlara baxaq. Bu gedir konfigurasiyada da gəlib çıxır. Geolocation works by mapping IP address to locations. However, some IP addresses aren't mapped to geographic location. So even if you create geolocation record that cover all 7 continents, Amazon Route 53 will receive some DNS queries from locations that it can't identify. You can't create a default record that handles both queries from IP addresses that aren't mapped to any location and queries that come from locations that you haven't created geolocation records for. If you don't create the default record, Route 53 returns a no answer response to queries from that used location. Dediyinə görə defaultla IP'si map olunmayanları edə bilməzsən. You can create default record that handles both queries from IP addresses that aren't mapped to any okay. Deyir, default record yarada bilərsən, hansı ki IP adresi hər hansı bir location'a map olmayanları handle eləyə bilsin və sənin geolocation record yaratmadığın yerlərdən request gələndə onları handle eləyə bilsin. Okay. Accessing a DNS server introduces a slightly delay. Although mitigated by cache described above, DNS server management could be complex and is generally managed by governments, ICPs, and large companies. DNS servers have recently come under DDoS attack, preventing users from accessing websites such as Twitter without knowing Twitter's IP address. Bir daha başa düşək. DNS servers have recently come under DDoS attack, preventing users from accessing websites such as Twitter without knowing Twitter's IP address. DNS architecture. Gəlin baxaq. Neyse. Well, content delivery network. Is globally distributed network of proxy servers serving content from locations closer to the user. Yəni sənə yaxın olan locationdan datanı serve edir. Generally, static files such as HTML, CSS, photos, videos are served from CDN, although some CDNs such as Amazon's CloudFront support dynamic content. Əslində static contenti deməli dəstəkləyir, amma bəziləri dynamic də dəstəkləyir. The site's DNS resolution will tell clients which server to contact. Serving content from CDNs can significantly improve performance in two ways. Users receive content from data centers close to them. Your server do not have to serve requests that CDN fulfill. Push CDNs receive new content whenever changes occur on your server. You take full responsibility for providing content, uploading directly to CDN, and rewriting URL to point to the CDN. You can configure when content expires and when it's updated. Content is uploaded only when it's new or changed. Minimizing traffic but maximizing storage. Sites with small amount of traffic or sites with content that isn't often updated work well with push CDN. Content is placed on the CDNs once instead of being repulled at regular intervals. Pull CDN grab new content from your server when the first user requests content. You leave content on your server and write URL to point CDN. This results in slower requests until content is cached on the CDN. Time to leave determine how long content is cached. Pull CDNs minimize storage space on the CDN, but can create redundant traffic if files expire and are pulled before they have actually changed. Sites with heavy traffic work well with pull CDN as traffic is spread out more evenly with only recently requested content. Well, buna GPT'den soracağım. Bu bir tane pull ve push CD'ni izah edersin. Mənə. Okay, types of CDN: push CDN, pull CDN. Push CDN, you push your content to the CDN server manually. How it works: you, the site owner, upload or push your static files to the CDN provider. The CDN stores content on its edge server. When users request the content, it serves directly from those CDN servers, not your origin server. Okay, you have full control over what and when files are updated. Ideal for static content that doesn't change often. Reduce the load on origin server because CDN already has the files. You must manually update, automate content synchronizing to CDN. Outdated content may stay cached if not updated properly. Example use cases: hosting app assets like logo, fonts, GS bundles, product image. Game asset distribution, software update hosting. Okay, pull CDN. CDN fetches content automatically from your server. How it works? You do not upload file to CDN manually. When user requests example cdn.example.com image png, CDN checks if it has file in the cache, return it instantly. If not, pulls it from your origin server, cache it, and returns it to the user. Future users nearby will get the cached version of CDN. Easy to set up. No need to push or upload files manually. Automatically cache what user actually requests. Great for website with many changing files. First request for each file is slower because it must be fetched from origin. Can add load to your origin server during high traffic surges if files aren't cached yet. News sites or blogs where content is updated frequently. Web apps with dynamically generated image. Sites that want a simple CDN setup with minimal configuration. Push CDN deməli fastı, amma pull CDN birincidə yavaş, qalanlarında sürətlidir. Many modern CDN providers offer hybrid solution push-pull. For example, you might push static during build time and let CDN pull images on demand. Okay. Globally distributed content delivery. Difference between push and pull CDN. Baxaq. Да, burada şey yok, hayır. Boş oldu var mı? Burası ne vaxt boş olacaqsan, ne vaxt oxuyacaqsan. Okay. Pick Burger to forward request, random round robin list busy, stick session cookie by request parameters. Wait for its response, forward response to client. Client, dispatcher, worker. Okay. Load balancer distribute incoming request to computing resources such as application server and database. In each case, load balancer return response from computing resources to the appropriate client. Load balancers are effective at preventing requests from going to unhealthy server, preventing overloading resources, helping to eliminate a single point of failure. Burası maraqlıdır bu. Single point of failure hissəsi. Yaxşı. Mənim klientimdən request gəldi. Mən bir dənə serverə getməsini handle edirəm. Single point of failure-ni aradan qaldırıram load balancerla. Mənim load balancerıma da load balancer lazımdır. Bəlkə mənim load balancerım çöktü. Onda nə olacaq? Mənə də maraqlı, çox maraqlıdır. Gəlin soruşaq ChatGPT-dən. I have a question. I am preventing single point of failure by using load balancer in front of the servers. What if my load balancer fails? All incoming traffic is routed to the load balancer's IP or DNS. If load balancer goes down, no request reaches your backend server, even if they are healthy. This is single point of failure at the entry point. How to prevent load balancer failure? High available strategies. Use multiple load balancer, active, passive, or active. Okay. Biz burada aktiv, pasiv o baxırdıq. Nə idi o? Availability pattern idi də. Bu fail over hissəsi. Active, passive, active. Onu deyir. One load balancer is active and handle all traffic. A second one stays on standby and takes over automatically if the primary one fails. Okay, başa düşdüm. Mən bu active, passive, master, slave, master ancaq elə bildim database üçündür. Amma deməli load balancerın özünü də nə etmək olar? Backup istifadə etmək olar ki, aktiv, passiv iki load balancerımız olsun. Biri fail edəndə pasiv olan onu götürsün və beləliklə pasiv istifadə edəndə biz determine edirik ki, nəsə problem var. Ya da aktiv, bir neçə load balancer var. Biz bir request birinə, o birisi request birinə göndəririk. If one fails, other keeps serving without interruption. Okay. Harda qaldıq? Load balancer can be implemented with hardware, expensive, or with software such as proxy. Okay, hardware or with software such as proxy. Additional benefit includes SSL termination, decrypt incoming request and encrypt server response, so backend server do not have to perform these potentially expensive operations. Removes the need to install X-point certificate on each server. Bu nə certificate'dir ki? Standard definition, the format of public key certificate. Using many internet protocols have public key. Okay. Session persistence issue cookies and route to specific client's request to same instance if the web app do not keep track of sessions. To protect against failure, it's common to set up multiple load balancer either in active passive or active mode. Load balancer can route traffic down on various metrics, including random list, loaded, session, cookie, round robin or wait round robin, layer 4, layer 7. Nedir bunlar? Layer 4 load balancing, bir daha bunları qeyd edeyim. Nədir? Load balancing, active, passive, active. Okay. Okay. Neyse bu qalsın. Bunun ardından sonra baxarıq. Salam, axşamınız xeyir. Load balancerdan başlayaraq qalanına sonra baxarıq. Yuxu rejimimi düzəltməliyim. Gərək qalxım səhərlər də oxuyam. Belə. Belə uşaqlar. Burada yekunlaşdırırıq. Qalanını da sabahdan davam edəcək. Load balancer, reverse proxy falan bunlar qaldı. Çalışacağım yayınları bu qədər gecə açmayım ki sizlər də gələ biləsiniz. Belə. Sağ olun. Gecəniz xeyrə qalsın. Özünüzə yaxşı baxın.